Okay, hello. Today we're at the California Science Center for the Endeavor exhibit, and we're going to look around and see what they've got. They've got two parts of the exhibit. The first part here is about the space shuttle itself, and then we're going to go outside into the special hangar to see the space shuttle. So come along and we'll see what we find. Let me find a little bit more video here. Well, here we are at last. A space shuttle main engine from the bell up to the pumps themselves. This was the part of the space shuttle that my dad worked on, with these pumps out at Marshall Space Flight Center. It's hard for me to see all of them clearly. I'm pretty sure that's the liquid oxygen pump on the top, though, and the liquid hydrogen pump, there you are, on the bottom. I was telling Lisa all about this from the diagram inside and how these stacked up against the old Saturn V engines. This engine is 8 feet in diameter at the tip of the bell versus a Saturn V engine which was 12 feet across. Now, Saturn V engine, just one of them, would produce 1.5 million pounds of thrust. We used 5 of them for a total of 7 million pounds of thrust to lift off a Saturn V rocket and go to the moon. This, however, is only 8 feet across. It's about 330,000 pounds of thrust. But the big difference is these pumps. The Saturn V, of course, had those same pumps, but they were not as powerful as these. The big deal for any rocket motor is how much pressure you can generate inside, right here at the pressure plate. Coming out of that pressure plate was about 3,000 psi for the fuel, a mixture of oxygen and hydrogen. For a Saturn V rocket, the pressure at that plate was only about 600 psi. And again, that Saturn V produced 1.5 million pounds of thrust. This, a smaller engine, lighter engine, produces 325,000 pounds of thrust. It's also burning a more efficient fuel, the most efficient fuel. When the fuel comes out of those pumps themselves, they're closer to 5,000 or 6,000 pounds of pressure, but they use some of that pressure to do some work, and they come down here and cool the bell. Using that high pressure fuel to do a little bit of work means they bleed off a little bit of the pressure. But when you understand that the Saturn V rocket used something similar to a kerosene fuel, and this uses oxygen and hydrogen, the most efficient fuel, you understand the difference, that if we had applied this technology to a Saturn V rocket, just how much more efficient those engines could have been and how much more powerful. But with this design, we don't need engines, we don't need those Saturn V engines like that anymore. We can use an engine like this instead. Alright, let's see what else we can find. These are the ones that know more answers to more questions.